All right, get ready because we're going to do a deep dive into some seriously awesome chemistry today.
Oh, yeah.
You bet. Our listeners have given us a fun challenge this time.
Lay it on me.
They want us to take a close look at 5 eco-friendly factoids from Cocktail Party Chemistry, specifically Episode 19, Sustainable Energy and Carbon Conversion.
Sounds like a plan.
It's all about chemistry's role in powering a sustainable future, and you won't believe some of this stuff.
Well, let's jump in then.
Okay, so first up, we've got biodiesel from microalgae. Renewable fuel from nature sounds pretty amazing, right? I mean, who knew those tiny little plants in the water could fuel our cars?
It is pretty wild, and what's really remarkable is how incredibly efficient microalgae are at converting sunlight into energy. They're way more efficient than traditional biofuel crops like corn and soybeans.
Wow. So we're talking about a much more sustainable way to produce fuel without gobbling up valuable land that could be used for food. But how do we actually get the fuel out of these microscopic powerhouses? Do they, like, squeeze the algae like little grapes?
Uh-huh. Not quite. It's a bit more complicated than that.
I figured as much.
It's a multi-step process. First, they extract the oil from the algae, and then, through a chemical transformation called transesterification, that oil is converted into biodiesel.
Transesterification, that sounds pretty intense.
It does have a certain ring to it, doesn't it? It involves specific catalysts and precise control over the reaction conditions, so you might want to leave this one to the experts.
Probably a good idea.
But the good news is this technology is already being used commercially. Several companies around the world are producing biodiesel from microalgae.
Really?
Yep, and it's only a matter of time before it becomes even more mainstream.
That is incredible. Tiny algae powering our world. Talk about a small package with a huge punch.
Okay.
Next on the list is solar fuels, converting sunlight directly into chemical energy. Now that sounds like something straight out of a science fiction movie.
It does, doesn't it? But it's a field of active research with incredible potential. Imagine capturing sunlight and storing its energy in a chemical form, just like plants do during photosynthesis. It's like bottling sunshine.
Okay, I get the concept, but how do we actually do that?
Yeah.
Giant magnifying glasses and test tubes.
Not quite. It involves these really cool materials called photocatalysts. They can absorb sunlight and then use that energy to trigger chemical reactions.
Oh, wow.
These reactions can then split water molecules to produce hydrogen.
Ah, so that's how we get the fuel.
Exactly. Hydrogen is a clean and versatile fuel. And get this, we can even convert carbon dioxide into useful chemicals using the same technology.
Hold on. So not only can we create fuel from sunlight, but we can also use this technology to actually reduce carbon dioxide in the atmosphere. That's like a double win for the environment.
Exactly.
But we're trying to mimic photosynthesis. Wouldn't it be easier and cheaper to just plant more trees?
Well, planting trees is definitely super important for combating climate change. But artificial photosynthesis takes a different approach. It lets us create fuels in a controlled environment, and potentially way more efficiently.
Right.
Plus, we can do it in places where trees might struggle to grow, like deserts or even urban areas.
So we're talking about a potential solution that could work side by side with natural solutions, like reforestation, like we're expanding our options for a sustainable future. This is really exciting stuff. But you mentioned that these photocatalysts can split water molecules. How does that actually work? Is it like zapping them with tiny lightning bolts?
Well, not exactly lightning bolts, but the principle is kind of similar. These photocatalysts absorb photons of light, which then energize their electrons. These energized electrons can then interact with water molecules, breaking the bonds between the hydrogen and oxygen atoms.
That's pretty amazing. Harnessing those fundamental building blocks of nature to create clean energy. I can see why you're so fascinated by this field. Okay, ready for factoid number 3.
Hit me with it.
All right, this one is all about artificial photosynthesis. So we're talking about actually mimicking nature to create fuel.
Precisely. Artificial photosynthesis aims to copy the key steps of natural photosynthesis, but in a man-made environment. Think of it like designing a system that uses sunlight to split water molecules
Okay.
and produces hydrogen, a super clean fuel. It's like recreating nature's magic, but in a lab.
So we're talking about creating artificial leaves then.
You got it.
That's wild. But why go to all that trouble when plants already do it so well?
Plants are awesome, no doubt about that. But artificial photosynthesis has some key advantages.
Ooh, like what?
For one, it lets us really control and optimize the process to be as efficient as possible. We can potentially make fuels faster and, like I mentioned before, in locations where plants just wouldn't thrive.
Ah, so it's like giving Mother Nature a helping hand.
Exactly.
It's like we're learning from nature and then using that knowledge to create even more sustainable solutions. This is blowing my mind. Okay, what's next on our list of eco-friendly factoids?
Next up is the world of bioplastics. This is where green chemistry is really revolutionizing the materials we use every single day.
Bioplastics. I've always been a little skeptical about those. They always feel so flimsy and don't always break down as easily as they claim. I've had so many so-called biodegradable bags that seem to last forever in my compost bin.
Yeah, I hear you. Early bioplastics definitely had their limitations.
That's for sure.
But recent advancements have produced some incredible materials. Think durable, biodegradable plastics made from renewable resources like cornstarch or sugarcane.
So we're not just talking about flimsy bags anymore.
Mm.
What kinds of things can these new and improved bioplastics be used for?
Oh, the possibilities are endless. Food packaging, disposable cutlery, medical implants even. We're even talking about building materials. Imagine a world where the everyday products are made from sustainable, plant-based materials that biodegrade naturally at the end of their life. That's the promise of bioplastics.
That's a game changer, for sure. But how do they go from cornstarch to something that can hold groceries or be implanted in the body? It's not like you can just melt down some corn and mold it into a plastic bottle, right?
Right, it's definitely not that simple. It all comes down to manipulating the chemical structures of natural polymers found in these plant materials.
Okay.
Through processes like fermentation and polymerization, scientists can transform cornstarch or sugarcane into these incredibly versatile bioplastics.
And these plastics have specific properties.
Absolutely. They can be strong and rigid or soft and flexible depending on what they need them for.
So it's like we're learning how to speak nature's language
Yeah.
and then using that to create the materials of the future.
You got it.
That's incredible. This is way more advanced than I ever realized. I'm starting to see how chemistry is at the forefront of creating a more sustainable world.
Hmm.
Okay, what's our final eco-friendly factoid?
Let's talk about something that sounds like it's right out of a science fiction movie, magnetocaloric materials.
Magnetocaloric materials. That sounds pretty intense. Are we talking about magnets that can generate heat? Like, I'm picturing some futuristic fireplace here.
Not exactly a fireplace, but
Right.
you're thinking along the right lines. These materials have this really unique property where they change temperature when you expose them to a changing magnetic field.
Okay, that is wild. How does that help us create a more sustainable future, though? Are we talking about some kind of magnetic power source?
Think of a refrigerator that uses a magnetic field to cool instead of those traditional refrigerants. That's the potential of magnetocaloric materials.
Wait, so no more freon or other harmful chemicals leaking into the atmosphere and damaging the ozone layer?
Exactly.
That's huge. But how does a magnet actually make things cold?
It's a bit complicated, but it has to do with the alignment of magnetic moments within the material.
Uh-huh.
When you apply a magnetic field, these moments align, and that releases heat. Take away the field, they become disordered again, and that absorbs heat.
Oh, I see.
It's like a magnetic heat pump.
That's incredible. So we could have this revolutionary technology that replaces traditional cooling systems and significantly reduces our impact on the environment. And it all starts with magnets. Who knew magnets could be so cool, literally?
And that's just a taste of what's possible with sustainable chemistry. These 5 examples really highlight how creative solutions are being developed right now to tackle our planet's biggest challenges.
I'm totally blown away. Algae-powered cars, sunlight-derived fuel, bioplastics that can do almost anything, and fridges that run on magnets. What else is out there?
Well, there's a whole area dedicated to carbon capture chemistry. Scientists are developing ways to turn carbon dioxide into useful products, believe it or not.
Carbon dioxide, the stuff we're trying to get rid of in the atmosphere. You mean we can actually use it to make things?
You bet.
Tell me more.
Think of it this way. Instead of thinking about carbon dioxide as just a waste product, we can start to see it as a valuable resource. Researchers are developing these amazing catalysts that can transform CO2 into a whole bunch of useful chemicals, methanol, formic acid, even plastics and building materials.
Wow. So instead of just capturing and storing carbon dioxide, we can actually put it to work.
Exactly.
That changes everything in the fight against climate change. It's like turning pollution into profit.
You got it. And that's just one example. The field of sustainable chemistry is overflowing with new ideas and innovations.
This is all incredibly exciting, but I have to admit, it's a lot to take in. I'm feeling a little overwhelmed by all this information. What does all this mean for the average person? How do we even begin to understand these advancements and how they affect our lives?
That's a fantastic question and one we should all be asking. The key is to stay informed, to be curious, and to talk about these topics. The more we understand about the science and the challenges, the better equipped we'll be to make good choices as consumers and voters.
So knowledge is power when it comes to sustainability.
Absolutely. The more we know about these solutions, the more we can demand them from companies, support policies that promote them, and make conscious choices in our own lives.
Makes sense. To support a more sustainable future.
Exactly. Every little action adds up, and together we can make a huge difference.
I completely agree. We've covered so much in this deep dive, but I know there's still so much more to learn. What are some of the other areas within sustainable chemistry that you're really excited about?
One area that I'm particularly fascinated by is the development of bio-based materials.
Oh, right. Yeah.
We've talked about bioplastics, but scientists are also working on bio-based alternatives for other things like textiles, construction materials, even electronics.
Wow, so it's not just about replacing plastics.
Nope,
It sounds like the possibilities really are endless.
they really are.
It's like we're right on the edge of this whole new era of material science where sustainability is built in from the ground up.
Exactly. And that shift in thinking is happening in other areas of chemistry, too. For example, there's a big push to use renewable feedstocks for chemical production to break free from our dependence on fossil fuels.
So instead of using oil and natural gas to make plastics and all those other chemicals, we can use plant-based materials.
Exactly.
That's a big step towards creating a more circular economy, where we're minimizing waste and using resources more effectively.
Precisely. And it's not just about solving those environmental problems, it's about creating opportunities,
Mhm.
new industries, new jobs, and a future where economic growth and a healthy environment go hand in hand.
This is so exciting. It feels like we're on the brink of a major paradigm shift, with chemistry leading the way to a future that's both sustainable and equitable.
I totally agree. It's an incredible time to be working in this field.
Well, before we get too carried away with our visions of a sustainable future, I think it's time to take a little break. Let's let all this incredible information sink in. We'll be back soon to continue our exploration of this amazing world of sustainable chemistry.
Sounds good. We're back, ready to dive even deeper into the fascinating world of sustainable chemistry.
I'm with you. All that talk about algae-powered cars and magnetic fridges, it's mind-blowing. What other amazing innovations are chemists working on to help us build a more sustainable world?
Well, let's talk about a field that often gets misunderstood. Green chemistry. It's not just about making eco-friendly products,
Love that.
much more. It's about designing chemical processes that minimize waste, reduce the use of hazardous substances, and conserve energy right from the start.
I like that.
It's like baking a cake with the most efficient recipe you can find. You're using the best ingredients, leaving the kitchen spotless, and getting a fantastic cake.
Okay, I can get behind that analogy. So how does green chemistry actually work in practice? Got any real-world examples?
Absolutely. One example is the development of catalysts that can make chemical reactions happen under milder conditions.
What does that mean exactly?
It means they require less energy and produce fewer byproducts. It's kind of like instead of using a blowtorch to light a candle, you just use a match. You get the same result, but with way less energy and a lot less fuss.
That makes a lot of sense. So green chemistry is all about working smarter, not harder, to make the chemical industry more sustainable. What other cool examples can you share?
Another exciting area is the development of bio-based solvents.
Okay.
Traditional solvents, a lot of which come from petroleum, can be pretty nasty for the environment.
Yeah, I could see that.
Green chemists are looking for ways to replace them with solvents made from renewable sources, like plants.
So instead of relying on fossil fuels, we can use plants to create safer, more sustainable solvents.
You got it. It's like using water to clean up a spill instead of some harsh chemical.
That's a great idea. But are these plant-based solvents as effective as the traditional ones?
That's a good question, and the answer is it depends. Not all bio-based solvents are created equal. There's a lot of research going on to figure out which ones work best for different uses.
I can imagine.
But in a lot of cases, they can work just as well, if not better, than the traditional ones. Plus, they're way better for the environment.
That's fantastic news. It seems like every time we discover something new about sustainable chemistry, it just opens up more and more possibilities for a brighter future.
It's true. It's like we're constantly adding new tools to our sustainability toolkit. And it's not just about specific technologies either. It's about how we approach chemistry as a whole. It's about moving away from that old take, make, dispose model and moving toward a circular approach.
How's that?
It means minimizing waste, reusing resources, and designing products for a closed-loop life cycle.
So it's about changing our whole way of thinking, not just making a few tweaks here and there.
Exactly.
It sounds like a pretty big undertaking. So what are some of the biggest hurdles in making this shift to a circular and sustainable chemical industry?
One of the biggest challenges is scaling up these new technologies and processes to meet the demands of the global economy. A lot of the sustainable solutions we've talked about are still pretty new, and it takes time and resources to bring them to market on a scale that can really make a difference.
Makes sense. It's one thing to invent a new material or process in a lab, but getting it produced on a large scale is a whole other ballgame.
Exactly. And then there are the economic and infrastructure challenges to consider. The chemical industry is a huge part of the global economy, and making it more sustainable will require big investments in new infrastructure and technologies. Plus, we need to see changes in how consumers behave.
It sounds like a massive change, not just a few isolated adjustments. It's a huge task, but the payoff could be huge, right? A cleaner environment, a healthier planet, and a more sustainable future for generations to come.
You're exactly right. It's a monumental challenge, but it's one we absolutely have to tackle if we're serious about a sustainable future. And it's not just the job of scientists and engineers. We need everyone to work together: governments, businesses, consumers, and communities. We all have a part to play in this transition.
Well said. That's a message we need to keep shouting from the rooftops.
Yeah.
Okay, before we get lost in the big picture, let's get back to those eco-friendly factoids. What's next on our list?
Let's talk about a technology that's been making some serious waves lately. Flow batteries. They're a type of rechargeable battery that stores energy in liquid electrolytes, which get pumped through the battery's cells.
Flow batteries. Okay, got to be honest, that one's new to me. What's so special about them?
Flow batteries have some serious advantages over traditional batteries, especially when we're talking about storing energy on a large scale.
Like what?
Well, for starters, they're incredibly scalable. You can boost their capacity just by adding more electrolyte.
That's pretty neat.
Plus, they're really durable. They have long lifespans and can handle deep discharges without getting damaged.
That's impressive. So are we going to be using flow batteries to power our homes and cars anytime soon?
Flow batteries are a better fit for stationary applications, like storing energy from renewable sources like solar and wind. Imagine these massive flow batteries hooked up to wind farms or solar arrays, storing energy when production is high and releasing it when the sun's gone down or the wind's died down.
That would be a game changer for renewable energy. It would help us get over one of the biggest hurdles with solar and wind power, the fact that they're not always available. We could finally have a stable and sustainable energy grid powered by the sun and the wind. But are there any downsides to flow batteries?
Well, they tend to have lower energy density compared to regular batteries, which means they need more space to store the same amount of energy.
Ah, okay.
And they can be a bit trickier to make and maintain.
Right.
But research and development in this field is moving fast. We're seeing some major improvements in their performance and affordability all the time.
That's good to hear. It's exciting to watch a new technology take off like that. Makes you wonder what other cool battery technologies are just around the corner.
One that's causing a lot of buzz is solid-state batteries. These batteries use solid electrolytes instead of liquid ones, which could offer some big advantages: higher energy density, improved safety, and longer life.
Solid-state batteries. That sounds almost too good to be true.
Yeah.
Are they really that much better than our current batteries?
They have the potential to be revolutionary, but there are still some technical hurdles to clear before they're everywhere. Researchers are working on developing new solid electrolytes that are both conductive and stable.
Makes sense.
They're also figuring out how to scale up their production affordably.
So we might have to wait a bit, but it sounds like solid-state batteries could be the future of energy storage. Can't wait to see how that plays out. But let's not get ahead of ourselves. What's our next eco-friendly factoid?
Let's talk about a tech that's been around for a while but is finally starting to get the recognition it deserves: fuel cells.
Fuel cells. I remember learning about them in school, but I can't quite remember how they work. Can you give me a quick rundown?
Of course. A fuel cell is kind of like a battery that runs on hydrogen. It takes hydrogen and oxygen and combines them to generate electricity with plain old water as the only byproduct.
So we can use hydrogen to make electricity without burning fossil fuels and without any emissions.
You got it.
That sounds fantastic. But where do we get the hydrogen? Isn't that a bit of a challenge?
That's a great question. Getting our hands on hydrogen sustainably is definitely a key hurdle for fuel cell technology to really take off. Most of the hydrogen we have right now is made from natural gas, and that's not exactly a clean process.
So we're taking a step forward with the fuel cell, but then a step back with how we make the hydrogen. Sounds like we need a cleaner way to produce that hydrogen.
Absolutely. That's why there's so much research going on right now into green hydrogen. It's hydrogen produced from renewable sources, things like solar and wind power.
So we're talking about using renewable energy to create a fuel that can then be used in fuel cells to create even more clean energy. It's like a perfect sustainable cycle.
Exactly. Green hydrogen is a critical piece of the puzzle.
But how do we make sure these technologies are accessible and affordable for everyone? Sustainability shouldn't be a luxury, right?
You're absolutely right. Sustainability should be for everyone. It's going to take a joint effort from governments, businesses, and communities to invest in research, create policies that support sustainability, and make sure these technologies benefit all of us, not just a select few.
That's a really important point. Sustainability isn't just about the technology. It's about social justice and fairness, too. Everyone deserves access to clean energy and a healthy environment.
Couldn't agree more. Sustainability is about building a world that works for everyone, not just a privileged few.
I like that. We've really covered a lot of ground here, haven't we? From algae-powered cars to green hydrogen and fuel cells, it's clear that sustainable chemistry is full of solutions to those energy challenges we face.
And we've just scratched the surface. There's so much more to explore and discover in this field.
I can't wait to see what the future holds. For now, I think we should give our listeners a moment to let all this amazing information sink in. We'll be back soon to wrap up our deep dive into the world of sustainable chemistry.
Welcome back for the final part of our deep dive into the amazing world of sustainable chemistry.
I'm so ready for more. We've already learned about so many incredible innovations: algae-powered cars, fuel cells, flow batteries. What else is there?
Let's shift gears a bit and talk about an area that's often overlooked, but it's super important for a sustainable future.
Okay, I'm intrigued.
It's catalysis.
Catalysis. That sounds familiar, but I can't quite put my finger on it. Remind me what that's all about.
Think of catalysts as the unsung heroes of chemistry. They speed up chemical reactions without being used up in the process.
Okay.
They're like facilitators, matchmakers, bringing those molecules together to make the magic happen.
Okay, it's coming back to me now.
Yeah.
But how does catalysis tie into sustainability?
Well, imagine you're building a house. You could do it all with hand tools, but it would take forever and a ton of effort. But if you had power tools, you could build that same house much faster and way more efficiently.
Right, makes sense.
Catalysts are like those power tools for chemistry. They help us make product more efficiently, using less energy and creating fewer byproducts.
Okay, so catalysts are like efficiency experts for chemical reactions. But how do they actually work? Is there some sort of magic going on?
Not magic exactly, but it's pretty darn close. Catalysts provide a different path for the reaction to happen, one that needs less energy to get going.
How do they do that?
They can bring molecules together in just the right way, weaken bonds, or stabilize those intermediate stages. It's like creating a shortcut for the reaction to follow.
That's really cool. So by using the right catalyst, we can make those chemical processes much more sustainable. Are there any real-world examples of catalysts making a difference in creating a greener world?
Absolutely. One exciting area is in developing catalysts for carbon capture and utilization. Remember, we talked about using carbon dioxide as a resource.
Yeah, turning pollution into profit.
Exactly. Catalysts are crucial for making that happen. They can help us turn that CO2 into valuable chemicals, fuels, even building materials, closing the carbon loop and moving us away from relying on fossil fuels.
So instead of seeing carbon dioxide as a waste product, we can actually use catalysts to turn it into something useful.
You got it. And that's just one example. They're used in so many things, making biofuels, creating biodegradable plastics, even coming up with cleaner energy technologies. Catalysis is really a fundamental part of sustainable chemistry.
It sounds like these catalysts are essential tools in our quest to build a more sustainable world. Are there any downsides to using them? Do they have any impact on the environment?
Like any technology, catalysts do have their potential drawbacks. Some are made from rare or toxic materials, and how we make and dispose of them can have an environmental impact. That's why green chemists are constantly researching and developing new catalysts that are made from abundant, non-toxic materials and that can be easily recycled or reused.
So it's about finding that sweet spot between performance and sustainability. Just like with any other technology, it's good to know those green chemists are keeping those environmental concerns in mind. Okay, what else is on our list?
Let's talk about something that's gaining a lot of attention lately, biomimicry.
Biomimicry. That sounds interesting. Tell me more.
It's all about looking to nature for inspiration, taking those designs and processes that nature has already perfected and using them to solve our own human problems.
So it's like stealing ideas from nature.
In a way, yes, but it's more about understanding why things work the way they do in nature and then adapting those principles to fit our needs. It's about respecting nature and learning from its 3.8 billion years of research and development.
That's a brilliant approach. Can you give me some examples of how biomimicry is being used?
Absolutely. A classic example is Velcro.
Oh yeah, that stuff is everywhere.
It was inspired by those tiny hooks on burrs that cling to your clothes. Another example is self-healing materials. They mimic the ability of living things to repair themselves. And when it comes to energy, researchers are looking at photosynthesis for inspiration, trying to create artificial systems that can capture and convert sunlight with that same efficiency that plants do.
Those are some incredible examples. So how do we actually go about applying these ideas in a practical way? Is it as straightforward as just copying what we see in nature?
Not always. It's not always a direct copy-paste. It's more about understanding the underlying principles and adapting them to fit our specific needs. It takes a lot of observation, analysis, and experimentation, and it often involves a whole team of people, scientists, engineers, designers, even artists.
So it's like a collaborative effort to find those sustainable solutions. That's pretty awesome. Are there any particular areas where biomimicry is really taking off?
Biomimicry is being used all over the place. Architecture and urban planning, materials science, energy production.
Wow.
For example, architects are designing buildings that mimic those ventilation systems in termite mounds to keep buildings cool naturally. And material scientists are developing new materials inspired by things like spider silk and seashells, strong, lightweight, and biodegradable.
That's amazing. It's inspiring to see biomimicry coming up with such innovative solutions. What's next for this field?
One of the exciting things is that we're now using powerful computational tools and AI to help us analyze and model natural systems. It's like unlocking nature's secrets on a whole new level.
Like having a cheat sheet.
Kinda.
Yeah.
But as we explore more and more, we have to be careful. We need to make sure we're learning from nature in a way that's respectful and sustainable.
Right. We don't want to solve one problem only to create a new one.
Exactly.
Well, we've covered so much in this deep dive. I'm feeling incredibly optimistic about the future of sustainable chemistry.
I am too. It's such a thrilling time to be working in this field, and I really believe chemistry is going to be crucial in building a more sustainable future for everyone.
I couldn't agree more. Thank you so much for sharing your knowledge and insights with us. This has been an incredibly eye-opening and inspiring conversation.
My pleasure. Always happy to talk about this stuff.
And to our listeners, thank you for coming along with us on this incredible journey through the world of sustainable chemistry. We hope you've learned some cool new things and that you're feeling as excited as we are about the possibilities for a more sustainable future. Keep those minds curious, and we'll catch you on our next deep dive.